2:40, right? Okay, I can go talk. Good afternoon, everyone, and thank you for coming. My name is Kazuaki Maeda from Chubu University in Japan. I'm very happy to be here, and we are one of the most famous cities in Asia, and it's the first time stay Taipei. Thank you for conference committee members and all of you. Thank you very much. And after lunchtime break, we feel sleepy, I think. So first, I break the ice. Before coming to Taipei, I've been to Bangkok in Thailand. So the famous water festival Songkran, one held then. So everyone has a gun, a gun filled with water. So and shot somebody. Sometimes somebody have a bucket and throw water. Okay, so but everybody smile. Smile is very important for human, and I'm a survivor, and I could come to Taipei. Thank you very much. And okay, the title of my talk is Parser development based on external DSL and internal DSL. This is one of the ongoing projects by myself. I have never lived in any foreign countries. I don't speak Chinese at all. I'm sorry. So sometimes my talk is not clear. If you have any questions, if you have any unclear points, please let me know anywhere, anyhow, by email or something you want. I don't talk funny thing. I'm sorry. If you feel boring by my talk, or if you are interested in my talk, please look at my website here, www.ragzone.org. I wrote this page with some links for my favorite open source tools. So I will upload today's presentation slide, I hope. Okay, here is an abstract of my talk. I explain parser development in Java using a traditional parser generator BRJ based on the external DSL, and I believe that an internal DSL is one of the approach, blah, blah, blah. So I designed on a subset of many bunch of lines, I'm sorry. So here is an agenda of today's talk. Firstly, I will talk about who I am. So secondly, I talk about the compiler front end. Thirdly, I will talk about DSL, which stands for domain-specific languages. And fourthly, DSL for syntax rules. And if possible, I will talk about structure of data and DSL. And finally, I will summarize my talk. So, who I am. Here's my background. I work at the university. Here is my background. I work at the university to give lectures about Java programming and software development, and I do some research project about web applications, XML, and compiler constructions. Moreover, I have some joint project with software companies, private software companies, to develop compiler front end. The programming languages of the compiler front ends I have ever developed for commercial products were VHDL, it's a hardware description language, and Java, SQL, C#, BASIC, and so on. But I don't have any graduate students, and I don't have any open source project right now. So I'm a sort of player. It means that I develop software by myself. Probably I write 10K to 30K lines of source code per 1 year. For the past few years, I developed reverse engineering tools to get design information from C# source code, and Java compiler frontend, and library for diagram editor, which was built by my sponsored company. Today's talk is based on the experiences in developing commercial products. Let's move to the next topic. I talked about development compiler frontend briefly. So I have two questions for all of you. First one, do you know tools for compiler construction? For example, Rex, Yak, Python, Antra, Java, CC. If you know, please raise a hand, please. Okay, thank you very much. 40%, 50%? I don't know exactly. Thank you. So second one is how long can you develop a simple calculator for the to read just a simple line 1 plus 2 star 3 and analyze and run and output the result 7. So how long can you develop? Okay, please raise a hand. 15 minutes. 15 minutes. Wow, excellent. Wow. 50 minutes? Awesome. 1 hour? Oh, excellent, excellent. 1 day. Oh, okay. 1 week. Or 1 month. Or never-ending story. So we are now very busy, right? So we have to develop it as soon as possible, ASAP. So we need tools. If we want to get lexical or syntactic items, we need to analyze the plain text. A compiler reads the plain text and analyze it lexically and syntactically and builds a tree to represent the structure on the source code. But the compiler does not export the analyzers out of the compiler. If we develop some software tool, for example, reverse engineering tool or source code search engines, we need to build a lexical analyzer called scanner and a syntax analyzer called Parser. Let's think about simple analysis of this expression 1 plus 2 star 3. Scanner reads a sequence of characters here, and skip white spaces and generates sequence of tokens here. Our parser is the next step. This is very simple. It reads sequence of tokens and recognizes the structure of the tokens. So we can calculate the multiplication 2 star 3 first here, and then we can add 1, and we get the result 7. This is very simple. Lex is a scanner generator. It reads definition of tokens and generates a scanner to recognize the defined tokens. The original version of Lex generates C programs, but for Java programmers, JFlex is available. Here is a lexical definition of the simple calculator. There is very simple. In left-hand side, over there, left-hand side, we can write some patterns using regular expression. In right-hand side, we can write actions when the characters match the pattern. You can download JFlex from the site. It's very simple. Download, make, and do it. To build the parser, we can use Yak. Yak is a very old tool. I think it designed 1970s. Well, Yak reads syntax rules and generates a parser to recognize the syntax structure. The original version of Yak generates C, just only C programs, but for Java programs, I'm Java programmers, and Java programmers, BYakJ is available. Here are syntax rules, very simple syntax rules for the simple calculator. We can write the syntax rules with recursive definitions using context-free grammar, like this. The parser generated from this definition recognizes only the structure. The important point is that the syntax rules are different from general-purpose languages, right? You can download BYakJ from this site. I have already written these links in my web page, so please look at my page. And JFlex, BYakJ, Mono C# compiler, GraphViz, blah, blah, blah. There are many links on my page. So if we need some calculations, we can embed action code in each syntax rule. For example, when the parser reads 3 symbols, E plus T here, and it executes this action code. $, means E in left-hand side. $1 is the first symbol E. $3 is the third symbol. The result of action code is going up over there. So, and when the parsing is finished, the parser holds 7. It's very simple. Now I will summarize only the topic, Lex and the Yak briefly. To develop simple calculator, developers write definition of tokens for Lex, definition of syntax for Yak, and the main method and other classes, other methods, blah, blah, blah. And to generate scanner using Lex and parser using Yak. So, and developers compile the source file using Java-C. So now I will talk about one of my works. Here is my background. I talked before. I developed reverse engineering tools to get design information from source code, C# source code. This is an example of the reverse engineering tool I have ever developed. It reads C# source code and generates, I'm sorry, what's happening to that? Okay. It reads C# source code like that. This is hello world, very simple C# source code, and generates class diagram right-hand side. This is my tool. This is my tool to generate class diagrams. If we build such a reverse engineering tool, we need to develop a compiler front end. We can develop a parser using a parser generator, Yak, for example, or BYACJ. In my experiences, it's not simple to develop the parser for modern programming language, for example, Java, C#, Ruby is also. If we can write perfect syntax rules for C# easily, we don't have any problems at all. But the reality is not. When I developed the parser for C# programming language from scratch, I wrote more than 800 syntax rules. And there were hundreds of conflicts in those syntax rules to be fixed. It's a time-consuming task to fix the conflicts. It takes more than a few weeks or 1 month. I mean that it's difficult to write completely perfect syntax rules. When I wrote Java syntax rule, it took the number of the rules about 600, 700 rules with many conflicts. It's a nightmare. Okay, so because the specs of modern programming languages are getting complex year by year. I developed C# programs for a few years, but to develop the reverse engineering tool, I didn't use Windows at all. I developed them on my Mac here using Mono. This is a very great tool, open source tool. The programs have already released for Linux, Windows, iOS, and Android. Here is a very simple example of the generated class diagrams from source code of Mono C# compiler. Mono C# compiler is written in C# itself. So this is only a part of the diagram. So my tool wrote the box labeled only class name, the very huge class diagrams, but zooming up, oh, I get it. Just only expression. So the diagram is drawn using dot. Do you know dot? Yes? Please raise a hand if you know. Oh, that's very few. It is a great language, right? Great language and great tool. I like it very much. So let's turn to DSL topic. So here is extracted from a DSL book written by Martin Fowler. He wrote the definition of domain-specific language. It's a computer programming language of limited expressiveness focused on a particular domain. There are he wrote 4 key elements. One is DSL is a computer programming language. It's used by humans to instruct computer something. Second one is language nature. DSL is a programming language and as such should have a sense of fluency. Third one is that DSL has limited expressiveness. It supports bare minimum of features. Fourth one is about domain focus. DSL is a limited language, and it's only useful if it has clear focus on the small domain. So, for example, here is one of DSLs, and my favorite one, and DOT. Dot is a DSL to draw diagrams. This is very simple description. Here are 3 nodes there, error 0, error 0, error 1, error 2, and two links. Why top region and bottom region is cut it? Okay. GraphViz reads this text and puts nodes and links them in natural layers for human. You can download GraphViz via this URL here. Here is just a little bit complex example of a dot. And there are many nodes and many links with label. GraphViz reads the text and draw diagrams like this very cute draw diagram. Here's the real output. This is a state transition diagram for parsing. Dot is a small language focused on drawing diagrams, but the language is different from any general purpose languages. So this is an external DSL. Once more, Martin Fowler wrote about an external DSL. The definition is that it's separate language from the main language of the application it works with. There are many examples: regular expressions, SQL, OOC, XML, and so on. There is other type of DSL. If we use Ruby language, we can use method calls as DSL. For example, here is to describe my laptop here. Processor type of processor is a Core i7 with 4 cores and speed 2200 and memory size 8 and type of disk SATA size 750, speed 5400. In the other case, if we use Java language, we can also use method chaining like this. These descriptions are based on a subset of general purpose languages. This is an internal DSL. So in Martin Fowler's book, he wrote definition of an internal DSL. The internal DSL is a particular way of using general purpose language, and it's a DSL represented with the syntax of a general language, and it uses a subset of the language features. We feel custom language rather than its host language, so I designed internal DSLs for syntax rules and structured data. I talked about syntax rules for the simple calculator using Yak. This is an external DSL. Developers write mixture of syntax rules written in the external DSL and action code written in another general purpose language, Java, C#, or so on. Action code is embedded in that each syntax rule located in the same file, like this. In this case, BACJ reads the definition and generates a parser. The Java compiler compiles the source code. The Java Java compiler, Java C compile the source code and generates bytecode for Java VM. But we make a when we make a mistake with no semicolon, the generator does not care about the syntax error. Here is a real output. The generator BACJ does not analyze Java syntax in action code. After generation, the Java compiler finds the syntax error, but it does not know where it happened in source code. This is one of the reasons I decided to develop new parser generator. So we're moving to the next topic on my DSL for syntax rules and parser generator. Based on the discussion until now, an internal DSL to define syntax rules was designed. I call it RibLR. I designed my tool called RibLogger to generate bottom-up parser. RibLogger stands for Language Analyzer Generator, but real reason is that I like Langer. I like Langer very much. This is a Thai beer, Sinha beer. I love it. Here is an example of RibLR. This is same syntax rules for simple expression in YAC. Here, express plus term. This is a same syntax. The keyword is token defines a token symbol. In the figure, three token symbols here, plus, mark, and number are specified. Important point is that this description is written in Ruby syntax, and there are internal method calls in Ruby. But when you fill it other language, this is an internal DSL. If we embed action code to a syntax rule, we can use an action method call. This method call here, and symbol data params is for holding the values of the symbols. Data params 0 is for colon term. Data params 1 is for colon term. Data params 3 is for colon number. We can run the action code for the multiplication. All the description of syntax rules and action code is written in Ruby. It means that Ruby processor checks the syntax errors. If we make a syntax error like this, the Ruby processor finds it before running and reports the syntax error. A generator called RibLogger was developed to generate a bottom-up parser, LR parser. RibLogger reads the user-defined syntax rules in RibLR and action code written in Ruby. After that, it generates a bottom-up parser shown the figure. The generated parser is composed of driver for parsing, action code in Ruby, and parsing data. After generating the parser, we can execute syntax analyzer. At that timing, we can switch action code to other type. The syntax of action code is the same as action code during parser generation. So let's move to the next topic. I talk about structured data and DSL. This is a picture I bought at Starbucks near to my home. I love Starbucks very much. Oh, also, here is a receipt written in Japanese, so I translate it. And it's a grande coffee frappuccino with extra short hazelnut caramel sauce, blah blah. There are 6 options. I use Starbucks as example of structured data. I can write the order in XML. This is very simple. Size here, size, product, and data last year, price, and the 6 options. Here is from a book beginning XML, and it's a buzzword. You know, everyone knows that XML is widely used in many applications. But based on my experiences, I think XML has positive side and negative side. On the positive side, it supports platform independence of programming languages, operating system, and computers. There are many libraries, DOM, SAX, XPath, XC, SOAP, and so on. But on the negative side, I usually say that there are 7 problems of highly effective XML, like the famous book by Stefan Covey. And there are many ugly tags, I think, and it's a human readable, but it's very difficult to read. I usually thinking which is better, attribute-based or element-based. And it's hard to run many specifications, a bunch of many specifications, XML schema, XLC, XML query, blah, blah, blah. And of course, hard to implement XML specifications. And namespace is very powerful, but it makes complicated XML documents. There is much between DOM APIs and application APIs. So JSON is other structured data representation. Do you know JSON? Of course. Oh, 3 minutes. I'm sorry. Oh, 3 minutes. Okay. This is a copy of website www.json.org. The feature is simplicity. It's easy for human beings and to read write, and it's easy for machine to parse and generate. So I took two types of representation: XML and JSON. XML is an external DSL, so that it's independent of any programming languages. JSON is an internal DSL, so that it's tightly coupled to JavaScript. I usually develop programs on Ruby, so I designed Ribbon as an internal DSL in Ruby. Here is a brief description. Ribbon is another notation like JSON. The design principles is simple. The one line is called an element in Ribbon here. In this example, the name is date and the value is string December 19th. The important feature of the Ruby, the parenthesis is optional. So this element is a method call in Ruby. So Ribbon supports 4 features: child elements and primitive data, 9 primitive data types, byte, char, short, int, long, float, Boolean string, and collection are represented by elements with the same name. Fourth one is the link across the structure. Links are represented using symbols in Ruby. Before using Ribbon, we have to define schema definition. I designed other internal data in Ruby. It's called RibSN. Here is an example of the definitions. But I don't have much time. I have to skip. I have been developing a generation tool called RibSyn. 1 minute. It reads schema definition and language specific definition, and RibSyn reads schema definition and language specific definition after being generate Ruby or Java source code. Okay, I summarize my talk. First, I talked about compiler frontend, the DSL, and talked about syntax analysis on my DSL Ribbon. Moreover, I talked about structured data and the representation in Ribbon. I talked about RibSN to define the schema. Software tools, including RibSyn and RibLogger, are still under development. The results will be published or open in open source world. All right, that's all. Here are my email addresses. If you have any questions or comments, please send the email to me. Thank you very much for your attention. Thank you.